Good morning, good afternoon, everybody. Welcome to this new session of the Dryden Pool Academy. I'm Flo, Pool Division Manager here at Dryden Aqua, and today assisted by...
Hi everyone, my name is Matthew Dryden. I'm the Chief Technical Officer of Dryden Aqua.
So Matthew, what are we talking about today in this session?
So today we're talking about ACO, but we're also comparing ACO with chlorine stabilizers such as cyanuric acid.
So you'll see ACO is a very unique, exclusive product we produce here at Dryden. You'll see, and we will explain you why it's really a game changer for you as pool professionals to use ACO in the future. So let's jump into the agenda of today. Dryden Aqua DAISY introduction. This means we want to again give you a short briefing on what we do with the DAISY system or biological approach to pool water treatment. Number two.
Why we use ACO and how does it work?
Number three is where and how to use ACO.
And fourth, we're doing the ACO testing, the chlorine stabilization of ACO and cyanuric acid.
And we'll finish with some ACO case studies around the world, followed by some promotion tools you will be able to use with your customers, read a bit more about ACO, and promote the product. So before we start, as the marketing manager, I have to do a bit of promotion. You know, we have created this new Dryden Aqua Pool Academy channel on YouTube with over 12 hours of online trainings. So this channel is really dedicated to these online trainings. You can subscribe, it's free. We talk about how to design a pool in a sustainable way. We talk about filtration, we talk about backwash, how to properly backwash a filter. We talk about chlorine byproducts, how to prevent them, public pools, pathogens, really very complete, free. So you just have to scan the QR code on the screen, subscribe, click this bell button to be notified when we upload a new video. The next one is a bit of promotion for my colleagues in the aquarium and aquaculture department, as well as the water treatment department. We also have dedicated channels with webinars. If you're interested in watching them, you can check them as well. Matthew is also in one of the water treatment webinar.
Yeah.
Okay, let's go to the subject of the day. And by the way, Matthew is the son of the Dr. Dryden, Howard Dryden. He's the founder of Dryden Aqua, and he's the one who really brought this new approach to pool water treatment with a biological approach. So far, the only solution was to always add more and more chemicals, more and more oxidants to the water to kill this bacteria. And he said, let's do it the other way, the biological way, by preventing the bacterial growth at the source instead of using always more chemicals to kill them. So this is really our message. It's prevent rather than kill. And it goes in 3 simple steps.
Yeah. So for this one, the biggest biological activity in a swimming pool is, of course, what's inside the filter. So by simply changing from sand is a good media for biological growth, whereas if it's replaced with AFM does not promote the growth of bacteria and biofilm. So simply replacing your sand with AFM reduces a massive amount of biological activity in your pool. This is the first step.
Yes, sand is the largest surface in AFM. The filter media is the largest surface in contact with water where you have this biofilm. And we remove this biofilm. We also filter them to 1 micron without flocculation.
Yep.
And with the step number 2, which is APF coagulant flocculant, we go down to 0.1 micron. So factor of 10, if I'm not wrong.
That's correct.
So this is really important, but also we take care of the dissolved pollutants in the water, such as organics, such as phosphates. All these are nutrients for these bacteria. So we want to remove all the food required for this bacterial growth. No food, no growth, very easy to understand. And the last and third step is the subject of today.
Yep, so ACO, how does it work? It is used to protect the free chlorine from UV rays. So we'll talk about it a little bit further on in the slide.
Yes, of course. So the DAISY results, we want to achieve the best possible filtration. Here with DAISY, we go down to 0.1 micron, and everything you can filter out, evacuate during the backwash process, you don't need to oxidize it. So we are able with DAISY to reduce this oxidation demand by up to 80%. compared to a traditional system. And who says, if you say less chemicals, less disinfectants, means also less toxic byproducts. So this is really what we want to achieve. Not only the best water quality, but also the best air quality without THMs, without trichloramines. And we do all this with the lowest possible operating cost, just by preventing bacterial growth at the source. So this is really the idea of your dad. And we are the only ones doing this on the market, but let's concentrate now on ACO. So why use ACO and how does it work? So ACO, again, like I said, is a very unique product and offers the very best alternative to cyanuric acid. Cyanuric acid, we know, is very good at reducing this free chlorine destruction. So it really protects chlorine from the sun. And you can see it here in the graph on the right. That shows the amount of cyanuric dose in the pool, the concentration of cyanuric, and the free chlorine remaining in the pool in percentage here on the left side. And this percentage of free chlorine loss in 1 hour, you can see that without any cyanuric in the pool, any stabilizer, 35% of your free chlorine is already gone in 1 hour.
Yep.
You start adding some cyanuric acid to the pool, 10, 20, 30, 40 ppm. You see that from 20 ppm, you already have a very good protection. You only lose 5% of your free chlorine in 1 hour. With 30 ppm, you're only losing 3% in 1 hour. So this graph shows you that it's doing a great job at protecting chlorine from the sun. It also shows you one thing, is that adding more than 20 ppm of cyanuric will not give you any extra benefit to protect this free chlorine. So from 5, it's already a good protection. You only get a few percent more by adding 30, 40 or more. So if you're using cyanuric acid, 20 ppm is more than enough.
Yeah. Any more and you get diminishing returns.
So how does it work and how does it really protect these chlorine molecules from the sun?
Yeah, so this molecule you see here is cyanuric acid, 3 carbon, 3 hydrogen, 3 nitrogen, and 3 oxygen. When it's added to a swimming pool, which has free chlorine in the pool, the free chlorine then wants to bond with the hydrogen molecule. So this creates a chemical called chlorinated cyanurate. So this chemical protects the free chlorine from being broken down by UV rays. However, it actually reduces the oxidation potential of the water, so you have to add more chlorine to have the same disinfection power than without.
Yeah, we come to the downside. Yeah, but this is really the reason, is when these chlorine atoms binds onto the hydrogen atoms, it's creating this bond, and then the chlorine is not anymore free in a way. So you have this chlorine locked effect, and this is really the downside of the cyanuric acid. So it protects it, yes, but then your free chlorine is not free any longer. So really the big downside of the cyanuric acid is that you will inhibit this chlorine effectiveness over time. Mm-hmm. The more you add cyanuric acid into the pool, the lower the level of active chlorine is. And you see it clearly here. We saw that the protection was very good at 30 ppm, but on the other side, your active chlorine level is only 43%.
Yep.
What does it mean? You need to add more than twice more the amount.
So you have to add more than double the amount of chlorine to have the same disinfection power than without the cyanuric acid. So the more cyanuric acid you have in your pool, the more chlorine you have to add. But what we see from the chart before, after 20 ppm of cyanuric acid, you get very fast diminishing returns. So the more cyanuric, the more chlorine, but it doesn't actually improve the disinfection power of the swimming pool.
And you all know this problem. After some time, you get to pools with 5 ppm of chlorine, but the chlorine is no longer efficient, and you have green pools with high level of chlorines, algae, and all these problems you meet usually in the middle of the season when it's the worst time to have these problems. So really not good for this. Saturated water, chlorine overdosage, unnecessary chlorine overdosage, and really the last thing is that it builds up in the pool water, so it's not being consumed. So over time, you will end up with saturated pool and the need to replace the pool water. The only solution is dilution in this case to solve the problem. Clear?
Yep.
And that's why we believe we have a much better solution than cyanuric acid with ACO. ACO will also protect, of course, chlorine from this UV light, but it's working a different way. Maybe you can explain to us.
Yep. So how the ACO works, when we add it to the pool, it actually changes the wavelength of the UV rays, so it goes from a short wavelength to a much longer wavelength. This prevents the breakdown or reduces the breakdown of free chlorine in your pool. Keep in mind that ACO does not react with the free chlorine. So we protect the free chlorine from breaking down, but it does not bond with the ACO. So our free chlorine remains free.
Yes, chlorine remains free. You have this short wavelength UV light, very aggressive for chlorine molecules, that you convert into longer wavelength UV light, which is a lot less aggressive for chlorine molecules. So we protect chlorine without reducing its effectiveness. At the same time, you don't have this building up in the pool, which means you will not have this problem with saturated water. You will not waste energy, you will not waste water and chemicals. So a much more sustainable solution for your pool. Last thing, the chlorine doesn't bond onto the ACO, so it's really, like you said, free chlorine remains free. So this is a bit the promise we do before giving you some more data, some more numbers and case studies. The benefits of ACO. With ACO, you will significantly reduce chlorine consumption compared to whether it is non-stabilized, of course, swimming pools, but also stabilized swimming pools with cyanuric acid.
Next up, it does not build up over time. As we mentioned, the ACO does not bond with the free chlorine, so the water does not need to be replaced. So no chlorine, water, and energy wastage.
Yeah. Third is you will see with ACO your water quality will be improved, generally with a lot less combined chlorine, lower turbidity, and this is because we don't reduce this oxidation potential.
Yep.
And it's actually quite the opposite with ACO. We tend to increase it. We cannot really make this claim because otherwise it would be considered as a biocide.
Yep.
But you will see that in most of the case studies, lower combined chlorine, lower turbidity with ACO.
And it's eco-friendly product, so it does no harm to the environment. So it is NSF 50 certified for swimming pools.
Yes. So this is a bit the promise of the product. And because it's a safe product, you can use it in a lot of cases, a lot of situations. Of course, all new and existing outdoor pools. If instead of using cyanuric acid, use ACO. It's compatible with all types of treatments. So of course, liquid chlorine, but also very good product for salt systems, saltwater pools. And if you're not using chlorine like bromine or peroxide, you can also use ACO. We know peroxide is also very sensitive to UV light, and ACO can also help you with peroxide active oxygen pools. And the last thing is also the filters, any type of filters.
So AFM filters, sand filters, cartridge filter, and DE filters.
Great. So public pools, private pools, of course, and also sometimes with more delicate forms of life, like you like to say.
Yeah.
Animals. So safe product you can use also in zoo.
So animals such as dolphins, penguins, otters, hippos, and sea lions.
Yes. So where to use it, now you know. And how to use it, also very easy to use. ACO can be dosed manually. This is our recommended way to do it because you have these active ingredients in ACO that tend to be settled in the bottle. So it's always good to give it a good shake and pour it directly into the pool. And really, if you cannot do it manually, you can also do it with a standard peristaltic pump on the return line before the pool water. And in both cases, same dosage, 2.5 liters per 100 cubic of water once a week.
Why a big shake?
So the active ingredient in the ACO may end up settling. So if you give it a good shake, then resuspend it. So when you add it to your pool, there's nothing settling on the bottom of the water.
Yeah. Good. So 2.5 liters per 100 cubic per week. You can now also do it monthly in some pools. If it's too difficult to do it once a week, you know that you can dose 10 liters per 100 cubic per month. This is also working quite well. But always the progressive way, we always prefer to do it the progressive way, once a week. Good. Let's jump to your testing, Matthew. So what did you test exactly?
Sure, so we go into my testing. I'm really wanting to compare the effectiveness of ACO, but also compare it with a similar concentration of cyanuric acid. So I'll show you, this is the laboratory and setup. We have a 1,000 litre IBC. It is then radiated with a mercury vapor bulb. This is a special bulb to emit UVA and UVB. These UV lights are the ones responsible for breaking down free chlorine. The tank is also heated using 600 watt submersible heaters. And then we have circulation pumps, 4 circulation pumps to ensure the water's nice and agitated, everything is free flowing. The water level is maintained at 600 millimeters, and the distance from the water surface to the bulb is 350 millimeters. This is very important for these tests, and we'll show you in the next slides why.
Why, yes. Can we make a break? It's really too hot, I'm sweating. Okay, we're back after the break. It's really hot here, it's ACO weather. I was too sweaty, so we had to make a short break. We're back on your testing, Matthew.
Yep.
So explain to us, so this you explained, it's how you set up your installation, and this is now the water conditions, huh?
Yeah, so I like to keep the water testing conditions the exact same for all of the tests. So first up we have the mains tap water. This is filtered mains tap water down to 1 micron, and then followed by an activated carbon filter. The temperature is maintained at 28 degrees Celsius. Then the conductivity is 330 microsiemens, pH 7.4, and the alkalinity and calcium hardness is at 130 milligrams per litre. Then we have the chlorine concentration. This is from 1 to 1.5 milligrams per litre of free chlorine. And the ACO concentration was done at 2 concentrations, 15 milligrams per litre and 25 milligrams per litre. And then the cyanuric acid, this was done at several different concentrations from 15 milligrams per litre all the way up to 60 milligrams per litre.
So 25 milligrams per litre is exactly the recommendation we give?
Yep. So
2.5 litre per 100 cubic, huh?
Yep, correct.
Good. So next, a few pictures of the installation.
Yeah, just
see how it looks like.
Top-down pose.
And now, again, why do we play with this distance between the water surface and the bulb for the test? This is really linked to this UV index, UV intensity.
Yeah, so the graphics we have on the right-hand side, this is quite important that we know the exact distance from the water. So the mercury vapor bulb, the closer you are to this bulb, the more intense the UV is. So we've worked out that if we have a 350 millimeters distance from the UV bulb, this will give us a range of UV intensity of between 6 and 8. And we've got a couple cities that we're highlighting here to show the different UV intensity throughout the year, but it's really what to look at the summer months when the pools are being operated.
Yeah, so this is, for example, Dubai. You see it's getting quite high, especially in the summer month. Vegas, we've also 7 to 8 during the summer month. Then a bit less with Alicante, 6 to 7, 7 in Athens as well. So this is really, that's why we really wanted to get this 6 to 8 set point for the test. If you take other cities such as Basel here in Switzerland, we're also in a range of 6 to 7. Same for Brussels. What's the difference is that it's on shorter or longer period of time during the summertime.
Yeah.
But basically, yeah, this 6 to 8 is a really good testing point and a bit less UV intensity for Brisbane in Australia, and also London with a UVI of 4 or 5.
Yeah.
But yeah, this is why we did this testing. This is why we have this distance of 350 millimeters. And now we can show you a bit the test results.
Okay, so up are the actual results of it.
So what did you test here again?
Here, if we show the graph, we've got the reduction in free chlorine when exposed to the UVI of between 6 to 8. So on the left-hand axis is the reduction in free chlorine, and on the bottom axis is the duration. So I go from 0 to 6 hours. First up, this one is, I'm calling it the baseline. This is just the water on its own exposed to UV light with no additional chemicals added. And here, if we look at the 3-hour mark, we've got a reduction of around 50% of free chlorine. So after the 3-hour mark, we only have 50% of the free chlorine left. And at the 6-hour mark, it's actually 80% of the free chlorine has been consumed. So we only have 20% of the available free chlorine
left. Yes.
Okay.
Now let's look at the cyanuric acid at 15 ppm.
So as we can see from here, the cyanuric acid is working. It's acting as a chlorine stabilizer. So same again, we look at the 3-hour mark. We've got a 30% reduction in free chlorine, and at the 6-hour mark, we have a 50% reduction in free chlorine, or 50% free chlorine remaining. Now let's look at ACO.
ACO 15, yeah?
Yeah.
Quite similar, a bit better.
Yeah, very, very comparable. And ACO performed just a little bit better. So at the 3-hour mark, we were just under 30, so
35.
a few percent less than the ACO, or we've got 3% more remaining free chlorine. And at the 6-hour mark,
45, yes.
again, it's around a 5% improvement over the cyanuric acid. Now we go on to the 25 milligrams per litre. So again, 3-hour mark, we've got just over 20% of the free chlorine has been consumed. At 6-hour mark, it's around 40%. And let's see what ACO looks like.
Really similar again, huh?
So again, the ACO is extremely comparable to the cyanuric acid. So at 3-hour mark, sorry, it's 20%, and at the 6-hour mark, around 40%.
So we can also take the takeaway is also that first we protect it. We reduce the need by 50%. In this case, instead of having 50 here, we have 20 here.
Yep.
Instead of 80, 40.
Yep.
But the big difference again is with ACO, the free chlorine remains free, which is
Correct.
not the case with cyanuric acid.
And we have a couple other concentrations to show you. So we've got the cyanuric acid at 40 milligrams per litre, and then one more at 60 milligrams per litre. But
So
we can
very good protection.
Yes.
But at these levels, the active free chlorine is very low. Yeah, very, very low. We've seen this in the previous chart. Yeah. Okay, good. So as a summary, ACO and cyanuric acid have very similar effectiveness at protecting free chlorine from the sun, from UV light. But again, remember.
Yep. So unlike cyanuric acid with ACO, the chlorine remains free chlorine, whereas with the cyanuric acid,
The more you add,
Yeah.
the more it goes down, the less free your chlorine is.
Yep, you have the chlorinated cyanurate. So you need to add more chlorine to have comparable disinfection properties of the water.
I think it's quite clear, yeah. Good. Okay, now some case studies around the world, because we give you our numbers. This is our test results. But let's look at the numbers, the results that our customers are getting and the customers of our customers are getting. We start here with a quite old case study of ACO, one of the first one we did in Spain, a very big aqua park called Aqua Natura in Benidorm near Alicante. And all the test results were sent via our pool distributor, PS Pool, who are also in Alicante. Very good company, by the way. If you're a pool professional in Spain, I suggest you talk to them. Very high quality products, very best service in Spain. And so in this case, the water park came to them and really wanted a solution to reduce the chlorine demand. This was a big problem. They have a water park of 6,000 cubic meters, so quite large, and a very high chlorine demand. So they were consuming 16 liters per cubic per year, and that was 96,000 liters of liquid chlorine per year. So they wanted a solution to reduce this consumption. Other problems was the combined chlorine a bit too high, 0.3 to 0.4, still okay, not so bad, I've seen worse. Very high turbidity of 1.2 NTU, but really the goal was to reduce this chlorine consumption. And all they did in this case was to manually dose ACO at 15 ppm over the season and to see what results they get. And these are the results. You see here before and after, and this is the consumption per year they had. So the 96,000 liters of liquid chlorine without ACO down to 67,000 liters with ACO of liquid chlorine consumed. So that's a saving of 29,000 liters for the year. So this is quite some trucks of liquid chlorine. Huh? Very good savings. Very easy to dose, and yeah, in this case, okay, 30% less chlorine demand. Also, turbidity was reduced by 40%, and also divided by 2 the combined chlorine levels, down to 0.7. Down to, sorry, here you see 0.2, yeah, 0.12 to 0.2. So very low combined chlorine in this case. Good. Now we jump to a more recent case study. We go to the US. We have a case study dated 2022 that we ended this year in 23, so very recent. And we just got the results from the Results World Las Vegas here. Very nice establishments, very nice pools. And we focused on 2 different pools there.
Yep.
You want to take this? Or?
Sure, so the 2 pools we have is the bamboo pool at more or less 260 meters cubed, and the temple pool at 270 meters cubed. So what we're looking at, we're monitoring the chlorine consumption, so in gallons per day, the ORP and the free chlorine levels. So here we're using ACO at 50 milligrams per litre, the cyanuric acid stabilised pool at 20 milligrams per litre, and of course the non-stabilised pool. So the goal was to reduce the volume of liquid chlorine and to maintain the chlorine disinfection required for the regulatory purposes.
Yeah, they're working with very high level of free chlorine in the US, in this case 4 ppm, which is huge for us in Europe. We don't see that usually. So very high level of free chlorine, and they really wanted to compare ACO with cyanuric acid and a non-stabilized pool to see the savings they could make. So these are the results. We start with the bamboo pool, 257 cubic. And you see here in this graph the chlorine consumption in gallons per day. So you see with the pool with cyanuric acid at 20 ppm, they had a consumption of 15 gallons per day. Mm-hmm. They stopped the cyanuric acid. They worked with no stabilizer at all, so no stabilizer, and this consumption went up to 20 gallons per day in July. And then they started to use ACO. And what you see during the season, the consumption went down, and we ended up with a consumption of only 7 gallons per day with ACO, those at 15 ppm.
Yeah.
So this is a quite huge difference, especially with the non-stabilized pool, of course. We have 13 gallons per day of difference, and this was, in this case, 10,000 liters of liquid chlorine saved over the period, over the season. So very good results, very good savings, 63% reduction in this chlorine dosing, while maintaining a stable ORP and a stable free chlorine level. A bit the same situation with the next one, the temple pool.
Yep, so the temple pool here, same chart as we saw in the previous slide. So the first column here, we've got the cyanuric acid. So this was around 13 gallons per day. Then we stopped that test and moved on to the non-stabilized pool. This consumed 29 gallons per day. And then after that, we went on to the cyanuric, the ACO testing at 15 milligrams per litre. And this was...
We got to the same numbers, same consumption.
Yeah, quite a good drop. So at 7 gallons per day, So what does this mean? We had a 73% reduction in the amount of chlorine consumed. So 22 gallons per day saved, and well, that's over 17,000 litres per season. Well,
yeah. So
very good
just
savings.
with these two pools, close to 30,000 liters of liquid chlorine saved. And you see also the difference between ACO and cyanuric acid in this case. We have a 45% difference in consumption, so quite important as well. So to remember the summary, ACO was able to save them 73% of chlorine compared to the non-stabilized pools. 30 to 45, average 40% of chlorine compared to the cyanuric acid pools at 20 ppm. And again, what we've been repeating.
Yep, the ACO does not reduce the ORP of the pool, and it does not lead to a chlorine lock. So there's no need to increase the chlorine levels to achieve the same ORP or disinfection properties.
No chlorine lock with ACO, and no building up, no need to replace the pool water, so pools don't need to be drained in the middle of the season because there's too much of ACO, like with cyanuric acid, which is quite a big problem. Good. I think you have learned a lot more about ACO during this short session. You know you can read more about it on our website, of course. We have all these case studies available on our download section, drydenaqua.com/downloads. Also some nice brochures you can download and share with your customers for DAISY, for ACO. And I wanted to show you again this quick video for the DAISY system. So DAISY, AFM, APF, ACO, really 3 simple steps to reduce operating costs in any swimming pools, new or existing pool. So I'll let you watch this video quickly.
To make swimming pools of the future more environmentally friendly, Dryden Aqua has developed DAISY, a unique and affordable biological approach adapted to all swimming pools' water treatments. In 3 simple steps, you can convert your pool to a DAISY pool to significantly reduce its operating costs, water and chemical consumption, and improve its water quality. How does it work? Step number 1. Replace your sand with AFM activated filter media. Thanks to its unique self-sterilizing surface, AFM fully prevents bacterial growth inside your filter and offers 50% greater backwash efficiency than sand, reducing your water, energy, and chemical consumption. AFM will also last much longer than any other filter media on the market for a guaranteed return on investment. Step number 2. Inject APF before your AFM filter using a constant flow peristaltic pump. APF removes all vital nutrients required for algae and bacterial growth, and, in combination with AFM, allows you to achieve the best possible filtration efficiency down to 0.1 micron. As a result, pool water becomes crystal clear, while chlorine demand is reduced by 50 to 80% compared to a traditional system. Step number 3. Use ACO, a natural and eco-friendly alternative to traditional stabilizers, suitable for all pool water treatments. Traditional chlorine stabilizers, such as cyanuric acid, have the major drawback of reducing chlorine effectiveness. After a few weeks, pool water starts to become saturated, resulting in unnecessary chlorine overdosage and the need to replace the pool water. ACO completely avoids these problems, protects chlorine from the sun without reducing its effectiveness. DAISY, the highest pool water quality with the lowest operating costs.
Okay, last thing, if you're looking for a Dryden Aqua distributor, you also can find them on our website under the contact button here. According to your country where you are, you will always find, we cover quite a lot of countries, you will find the Dryden Aqua distributor where you can find AFM, where you can find APF and ACO. And we hope you enjoyed the session of today.
Yep. Thank you for joining us.
Thank you for watching, and we see you next time.
See you.
Bye-bye. Ciao.